Sock Monkey Math presents the Russian peasant method of multiplication. Let's illustrate the Russian peasant method with a problem. We'll start with the problem 54 times 17. So this is what we're going to multiply. And you'll see that in the Russian peasant method, it's not necessary to memorize multiplication tables. We can do this simply by dividing by 2, cutting things in half, multiplying by 2, doubling things, and by addition. So we'll employ the Russian peasant method to work this 57 by 17 problem. And you start by writing your factors opposite each other. 54 there and 17 over here. Now I'm going to create a column of figures under the 54. Each new figure will be twice the figure above it. Will be half the figure above it. On this side, under the 17, I'll be doubling 17, so each figure will be twice the number above it. So let's get started now and just see what this looks like. When I have a remainder, I'll throw the remainder away. So this is integer division. 54 and half of that, or 54 divided by 2, is 27. That one worked out exact. 17 we have to double. That's 34. Now just repeat the process. 27 divided by 2, that's 13. There was a remainder of 1, but we'll throw that away. 34 doubled would be 68. 13 we're going to divide by 2 and we get 6. There's a remainder, but we'll throw it away. 68 doubled would be 136. 6 cut in half is 3. 136 doubled is 272. The 3 cut in half would be 1. Again, throw away the remainder. Double the 272, and you get 544. Now, we're almost done. A couple more steps. We'll go back to our double columns, and any row that starts with an even number, for example, the first row starts with 54, which is even. We're not going to use that row, so we'll just cross it out. 27 is odd, so that stays. 13 is odd, that one stays. But the 6 is an even number, so we'll get rid of that row. The 3 and the 1 both commence rows with odd numbers, and so they stay. What's left? We'll come over to the right-hand column, and I'm going to add what's left. So what do we get? 4 and 8 is 12, and 2 is 14, and 4 is 18. Carry a 1. 3 and 1 is 4, and 6 is 10, and 7 is 17, and 4 is 21. Carry a 2. There are no hundreds until I get down here. So 2 and 2 is 4, and 5 is 9. So when I added what was left, I have 918. What's the significance of 918? Let's go back to the original problem. 54 times 17, and we'll just use the multiplication algorithm that you learned in grade school. 7 times 4 is 28. We're going to carry a 2. 7 times 5 is 35, but carried a 2, so that's a 37. 1 times 4 is 4, and 1 times 5 is 5. Now we draw this bar across here, and we do some addition. So I've got an 8, and a 7 and 4 is 11, and 1 to carry, and 3 and 5 is 8, and 1 is 9. Well, look at this. I did conventional multiplication on the bottom, and I've got 918 for a product. I did a Russian peasant method, which involved only doubling, dividing by 2, and addition, and I got 918. Of course, the question would be, does that always work? And if so, how did that work? So let's see if we can figure that out. I'm going to get us a clean sheet of paper. And on this clean sheet of paper, I have our two columns, and these are precisely the way they were a moment ago. Now I'd like for you to recall what the next step was. The 17 you can think of as a 17 times, we haven't done any doubling, so it's times a 2 to the 0. 2 to the 0 is 1. So the 17 was simply 17. The 34, I got that by doubling the 17, so that was 17 times 2, which I could think of as 2 to the 1. Now to get the next number, I doubled the 34, and I got 68, but this was already 17 times 2, so to double that, the 68 we see would be 17 times 2 to the second power, which would be 17 times 4. 17 times 2 multiplied by 2 again, you've got 17 times 4. And in the same way, this 136 would be 17 times 2 cubed, 17 times 2 to the 4, 17 times 2 to the 5th power. These numbers are always equal what's immediately to their right. Now what was the next step in the method? Anything that was even over here we crossed out, so let's do that again and just get rid of these values. And this was an even, so we'll just get rid of those. And then the next step was to add these, but the numbers that survive in this column are exactly the same as the numbers here, so I'm going to add the numbers in this column. And I'm going to do it not in column fashion, but I'm going to do it in row fashion. And I see that I've got a 17 times 2 to the 1, and then that would be a plus 17 times 2 squared, and plus the next survivor is 17 times 2 to the 4, plus, and the last would be 17 times 2 to the 5. And that's equal to, well, each of these terms has a 17, so we can factor that 17 out, and I'd be left with 2 to the 1 plus 2 to the 2 plus 2 to the 4 plus 2 to the 5th power. And that's equal. I'm going to convert, just for our ease of recognition, these numbers to their, not their exponential format, but their integer format. So 2 to the 1 is a 2, and 2 to the 2 is 4, and 2 to the 4 is 16, and 2 to the 5th is 32. Now what do I have? I'm going to add up the terms inside the parentheses, and so I've still got a 17 here, but now that is times, and I've got a 2 plus 4 is 6, plus 16 would be 6 and 16 would be 22, and 32 would be 40, would be 54, wouldn't it? So this would be times 54. 17 times 54, which is of course is the same as 54 times 17, and that was the original problem. So this tells me that when I do the Russian peasant method, all that we're doing is converting the factor on the left into a sum of powers of 2 by subsequent doublings. So, of course, the addition is equivalent to the multiplication. That's a very neat trick. You don't need to learn any multiplication tables other than the 2's.